Welcome everybody to Data Talks on the Rocks. I'm excited today to have as my guest Simon Späti. Simon, welcome to the Data on the Rocks podcast.
Thank you so much for having me. Yeah, I'm looking forward to our talk. Yeah.
I thought I would in my own words introduce say a few words about your background, and then we'll get right into some of the topics of discussion. But you and I have been following each other on the internet now for quite a while as two folks very excited and interested in the data world. You've been a data engineer, a technical writer, a blogger. I've been following your blog for quite a while, and most recently, we've been working together on a number of essays on interesting topics in the data space. And you're also an author of a book called Data Engineering Design Patterns, which is available. We'll certainly share links after this and in the transcript for folks who are interested in learning more. But I guess I just want to start before we dive into some of the contemporary topics in the data space, just about a little bit about your background in your own words, how you got into data. It's been a couple of decades you've been working at various roles, various companies, now as a writer and freelancer and author. But yeah, tell me a bit about your journey into this data space, how you got here.
Yeah. I have a bit unorthodox life path, I would say. Yeah, I started in 2003 as an apprenticeship as a computer scientist. So here in Switzerland, we have this dual system where you can actually work and study at the same time. So that gave me a head start. So I have like 4 years of apprenticeship where I already have like actual work. So there I worked with Oracle, SAP. I was in the service desk, and I really got into all the different parts. And then at the end, I basically choose between SAP and Oracle databases because that was the one that interests me both. Both were with databases related. So at the end, I choose the Oracle database. And from there, yeah, first day, of course, I moved to a bank, and there we had like data warehouses. We did the traditional ETL, and that's actually how it all started. So we had a lot of bash scripts starting all our ETLs. We had a lot of, we had like a ODS, operational data store, where I had like the intermediate fast querying data for like anomaly detection and stuff that had to be on the fly. And then we had a long-term data warehouse where we do like reports on if everything is okay, if the customer if the money is correct and everything. So that was basically in 2007, I would say. And yeah, I started also like my domain. I opened up in 2004, quite early. And then I always tinkered with it. I had at some point I had a party website that was before Facebook and everything. So there I was the guy who people came to, and when we were like on parties, then I took the pictures. I did that with like PHP, HTML, and CSS, and that's actually how I got into the web development a bit. So and that stayed with me up until today. I still have that. I changed the domain, but all domains still reroutes to my current domain. And yeah, fast forward, I was like starting doing consulting work. Then I switched to Microsoft SQL because the demand was higher than Oracle at that time. Later, I went abroad for 3 years in Copenhagen to practice my English. So you hear I'm not a native English speaker. So, but there I really got into the language. I read more books. I got into the Tim Ferriss podcast. I listened all the great people, and then I started to listen more books. And then also that's when I started to write my first blog post. I think one of my first was data engineering, the future of data warehousing. So I was actually at the right time when data engineering was started, right? So data engineering is not that old yet, but before it was like a BA engineer. And I was mainly writing about the convergence or the difference between them. And then also in Copenhagen, I got more into the big data, as it was called back then, right? With that was my first experience with Python. Before I was just doing store procedure on PLSQL or TSQL on Microsoft or Oracle. But then we did like a data science hackathon. The whole Airbus was flying to Toulouse, and then we did a 2-day hackathon on the Flight Radar 24 data, and that was really my first experience with a little bit more programming, and really also the fun stuff that really I liked, and then also that stayed with me. And yeah, then at some point I went back to Switzerland. The writing got more and more involved. That also, after that, I started as a data engineering and technical author at Airbyte. So actually, I was kind of making the writing as my part-time job or a full-time job, if you want. I still do the data engineering and then writing about it. So and then yeah, now today I'm started since 2 months. I started my own company, so to speak, and yeah, full-time author at the moment, but I'm still doing data engineering and everything related to open data engineering. So yeah, pivoted from basically BI engineer to data engineer to author and writing my book. So my book is not finished, so it's an unfinished book. So, but I'm planning to, yeah, I don't give myself a deadline, so I can really do like whenever I have something to write, I really deep dive into a chapter, and I release chapter by chapter. It's online, and yeah, that's what I'm doing on the side. But yeah.
What you talk about your journey to becoming now a data engineer and author. I think one thing that you and I discussed over the last few weeks is, and recently there was an article from Chris Riccomini about what do we call those of us who work in data? Are we analysts? Are we data developers? Are we data engineers? What what do you think is the right term to describe somebody who is working on, kind of from soup to nuts, from data to dashboard, on these data stacks? What's the term of art that you would use?
I would ask the first question, where do you live? Because I think it really depends, or where are you living at? Because here in Europe and here specifically in Switzerland, maybe things are a bit slower than in the US, right? Where I mostly connect and write about. So yeah, I'm not even sure if the data analysts arrived here. So I would still say that is now it's already dead, but here it didn't even arrive yet. So and also DBT, and it's getting bigger and bigger. But yeah, I would say it depends where you live, and I'm also not so keen on really for me it's like, yeah, before it was DBA, a database administrator, right? But we still have DBAs today, and I just think for me the business intelligence engineer knows a little bit more about the business and really has that hat on, and maybe the data engineer is more like with Python and program. But there is a whole different area. A data engineer could also, depending on the size of the company, could do DevOps, could like ramp up the whole platform. But it really depends where you live and which company you work at. And but an analyst, I would say, is also kind of a BI engineer, right? Because both an analyst is really knowing the domain, is the domain expert, knows the business, and that's what a BI engineer is doing as well, right? Maybe an analyst, if you really want to separate them, is doing more hands-on programming.
Right.
But at the end, I guess an analyst, for me, it's always a synonym for a DBT. If someone works heavily with DBT and not much further, then that's kind of an analyst for me.
Mhm.
But yeah, I think there is many definitions and overlaps, and but yeah.
Seems like a trend, at least I've observed, is a lot of folks start out working at the application layer, whether designing dashboards with Tableau or um, Metabase or Superset or Power BI or Looker, and then they end up bit by bit moving deeper and deeper into the stack, because that's frequently where kind of the biggest
Hmm.
challenges, the thorniest challenges, or the gnarliest knots are often found, right? In not the application layer, but at the database layer, where you have to think about data modeling, and then once they're working on data modeling, they maybe in the database they start thinking about orchestration and start going sort of one step below. Um,
Yeah, totally. Yeah.
well, one topic that I thought we would bring up, because you and I are again very active, even more so than I am, active members of this kind of virtual community of data practitioners. And in the last couple of weeks, probably the most exciting thing that's happened in the data world has been this, I think, vast migration of folks to from X, formerly known as Twitter, to Bluesky. And I guess the second thing that's related to Bluesky is not just that it's a virtual community that I think has some qualities that we appreciate, but also it itself has some incredibly rich data that is open and available. That's kind of a dream for data scientists or data engineers, or whatever we want to call ourselves. I guess I would ask you, and maybe we'll get into both topics, but first, why, what's your opinion? What changed? I think the data community was kind of casting about for a place to live. There's Slack channels like DBT that has a pretty healthy community. Um, but what do you think has changed in the last few weeks, and why suddenly is, the folks are landing on Blue Sky?
I think there's multiple reasons. First of all, it's like, um, yeah, the everybody was kind of searching for a new place, right? And then it's like, do you go to Threads, or do you go to LinkedIn? Do you go to Instagram? Or yeah, every platform has their own like kind of advantages. But for me, when I saw Blue Sky, and then it felt like another Twitter. So it's like I felt immediately like home. And then the more I used it, and the more I got to know the background of it, I think it's so fascinating how it's built. So I didn't know that in the beginning, but yeah, they have everything. It's like an open social network, right? And then you have the even yeah, the app is open, but on top of that, you can build multiple apps. But then also the protocol, it has its own protocol. So yeah, the at proto. So if Blue Skies goes away, you have all your data. You can build. In fact, there's already two other like UIs that I know of. It's like a hacker alternative, and like event RSV kind of platform where you can kind of approve or go to events, and they're all with the login of Blue Sky or the AT Proto, right? And then it just opens up like the Pandora box of possibilities, because you can do so many things, and on the top of that, even the data is open, right? So yeah, you can directly go to the API, do a DuckDB query, and query your last 100 posts. In fact, I did that on my own um, blog post or posts on Blue Sky. And on top of that, there's also like a chat stream that is just like streaming the whole. So there's funny implementation of that. So you can just open it, and then you see all the posts coming at you, right? So it's really interesting that you can just plug in. It's almost like, I think Twitter had it before as well, right? That it was like the API was open, now it's closed, or you pay for it, and it's also yeah, especially for data people, so we can actually analyze the whole social network. And yeah, I think you also did some fun experience experiment there. So
Right. The last week, I think a lot of us have just we've all been diving into this rich signal stream, because right, it's not every day that this kind of data becomes available, and I hope it stays open and available. I think I'm optimistic. Certainly, that's a core value of this of this organization. I'm not sure they're not quite for profit. I think they're a B Corp. Um,
Mm.
but of course, we all saw that OpenAI started out as a nonprofit and then went in a different direction. So hopefully they'll stay the course here as uh, open and public and available with all of their data the way they are today. I think
Mm.
um, I think the other thing that's amazing about Bluesky is it's such a small group of folks. It's only about 20 people in the entire company. And here they are um, currently, I think last I checked, right, they now have over 20 million users. So it's
Yeah.
pretty remarkable what they've been able to achieve in terms of their infrastructure, um, to be able
Yeah.
to probably
On-prem, everything runs on-prem, right?
right. And they're running their own servers. I think
Yeah.
Uh, yeah, I think for some cost reasons, they made that choice. But they've got, I think, Martin Kleppman
Yeah.
advising them, the author of building data intensive applications. So they've got some smart people involved there, and I think obviously the fact that the site remains available and up during this massive spike is again a testament to that very thoughtful architecture. Um,
Yeah, it's amazing. Also the that you could even run your own servers, right? If you want, you could have your posts run on your own server. I think
yeah,
they have this personal data servers, PDS, and the implementation of Bluesky is based on SQLite. So it's every user has their own SQLite database,
right,
and now they have maybe around 20 million
right, right.
SQLite. It's so interesting, yeah, how they build it, right? It's yeah,
Well, so I think we talked about using Bluesky data as a maybe as a way to talk about data stacks more generally. I think what's exciting today is there feels like we're the data space has always been, for those of us who are in it, an exciting place, but it does feel like something's some tectonic plates have shifted in the last couple of years in data. And I thought one of the goals of you and I connecting here is to talk about some of these big trends that are these macro trends that are happening. I think maybe speaking of SQLite, maybe we'll talk about an analogous technology to SQLite, which is DuckDB. I had as one of my guests on Data Talks on the Rocks, Hannes, the creator of DuckDB, and his inspiration for DuckDB was to build a SQLite, but for OLAP, right? SQLite is transactional and DuckDB is of course analytical. What you've been doing a lot of work with DuckDB. What do your in your perspective, why do people love DuckDB? Where does it shine? You've been doing some writing for Mother Duck, which is obviously a commercial company that's building the DuckDB in the cloud, and talking about use cases for DuckDB in production. What from your research and your writing, what are you seeing around why people are so attracted to this technology and really, I think most interestingly, like, yeah, where is it being used? What are the use cases in production for DuckDB?
yeah. For me, when I first encountered it, it was like a dream come true in a way because, yeah, when I started my career, we started with SSAS, so that's the analysis services of Microsoft, and we use them everywhere. I think they're still heavily used today because they're just so so fast, right? If you want to on your dashboard, your sub-second response time, you need a very fast backend, but it was just always so hard, especially with SSAS. It was like a drag and drop or click tool, so everything needed to be clicked. And so if you had like many cubes, you had to go through it. You couldn't really version it because there was like IDs and graphical stuff within the code, so it was really hard. And then yeah, like a decade later, we had like an open source all app solution like ClickHouse and Druid and Pinot and all this great stuff that is out there now. But it's still very heavy or it gets easier and easier, but it was still hard to kind of ramp up your own servers, right? Because they're really, really fast in also event data, so you can really stream in like large amounts to it. But then if you also need to, they have their back server, they have like the front end, so they have many or like processes running, right?
Various services, right? Like
Services,
Druid has almost half a dozen services that you need to run.
Yeah, and then I think now I don't know, is that 10 years later again? Is like, or 5-6 years later? Now we have DuckDB that you can just brew install DuckDB, and then you have like a OLAP that is fast. And that was the first thing, right? You just have a fast OLAP, although it's not like a huge server. It's more local first, obviously, but it can handle. Or the data that we handled back then, it can easily be handled with that now. And but I think also the fact that you can now do many more, that's only what I encountered later, right? You can, with Rill, right? You have like a interactive way of fetching the data instead of waiting to import the data and then see what you have and then click. So you can interactively explore your data. That's like one use case. Or one that I really like is like the zero copy layer. So actually DuckDB is mostly not used as a storage, right? It's mostly used as just as this intermediate layer that makes everything magically faster. So once I had to export from Postgres to Postgres, and then like you do like a data dump and then you import it again, right? But if you use DuckDB in as a like in memory kind of or a zero copy layer, that speeded up the whole thing. Just because it has a faster reader, it uses some advanced technology. That's other cool use case. And because it's just a single binary, like also same as SQLite, you can also run it as part of your pipeline. It also opens up for enterprises. You can do like more secure if the data shouldn't leave your web browser, right? You could run it within the web browser, or there's also Wasm that is quite popular.
What was the I think you wrote that blog post about folks who are using it in production. Maybe what would you highlight as one of the most interesting use cases in production where DuckDB is being used in production, and how is it being used in that company?
There's I think Okta was very interesting. There's a whole YouTube video from Jake Thomas, like the processing 7.5 trillion records. And they have a very cool architecture, right, where they split it in multiple DuckDB processes. Or also just a startup that has like 3-4 people, I think, that spare course. They do like cloud analytics based on cloud infrastructure. And I haven't dig too much deep how they really do it, right? But they say they use DuckDB for the like, I think they do a lot in like the browser and analytics on the fly instead of having a very large backend. And also Hugging Face, that they built this protocol, right, that you can directly query all their models directly from there. So I'm more fascinated almost by the different use cases it allows to than the one single one, right? So there's so many. You can use it as an interactive data app. You can like do pipeline processing, or just have your lightweight compute that you can do your test before you go to the cloud, where it's very expensive, right? So you can do a lot of things beforehand, and then if you really need a big class, you can still use Spark, but maybe the CI/CD stuff and can all be done locally, and then you save a lot of costs, right? There is a big factor, or many say they save a lot of money and speed, right? So this is, I think, the biggest themes I see apart.
It seems like one of the macro trends that DuckDB has been kind of drafting off of is this shift towards object storage. So we've seen obviously S3, Amazon's S3 as this foundational fabric for where data lives, and the fact that DuckDB, I think all of us really love that ability just to write a select from an S3 bucket directly with one line of SQL and query the data. And in fact, as you mentioned, the ability to sort of DuckDB doesn't even need to really be storage, right? It's simply a compute engine, and your storage is actually your data lake or your object store, the Parquet
Yeah.
file living there. I think what among choices that people are making in their data stacks are, okay, where do we put the data? Do we put it in a data lake or do we put it in a Snowflake? That's often one of the first questions that data engineers have to answer. They also need to, if they do put their data in a data lake, answer the question of what's the format of that data? Should it be God forbid, CSV or Parquet or gzipped JSON? Should it be a Delta Lake or Iceberg? And now, of course, those are both under the umbrella of Databricks. And then we also can talk about, once they've made those choices, there's other choices that need to be made as in the data stack of what language do they want to use to operate on that data. So maybe maybe we'll even go one step back, which is before we talk about thinking about the architecture of this emerging modern data stack that's out there, and modern should be kind of in heavy quotes. Before we even talk about landing the data, you obviously worked at Airbyte in the past. The first step to sort of working with data is getting access to data, is ingesting the data, orchestrating data from a source. What have you seen as sort of best practices and emerging technologies in the space of orchestration of just to be maybe concrete, you and I were talking about the jet stream from Bluesky. Well, it's very easy for anyone to say, oh, I'm going to go grab, in real time, a feed of, even a few 100,000 Bluesky posts. That's easy. But it's far harder to say, I'm going to set up a service that is going to continuously ingest 100,000 posts a minute. I think right now, last I looked, it was about 100,000 posts, events a minute are coming across the Bluesky stream. And if we were to build a data stack that was making sense of this stream, getting a durable ingestion architecture up would be, I think, the first challenge. What are you observing these days in the space of, there's Airbyte, there's Dagster, there's Airflow, there's I think Mage is a new entrant to the space. Tell us a little bit about orchestration and what you're seeing on that sort of layer of the stack.
Yeah, if you were to build like a data warehouse, or it depends what you want to do, right? It's like the class. I always think it's, yeah, as you said, you can just export them and do some analytics with DuckDB, and then you're fine, right? And then you can put a BI tool. But if you want to really make sense of it, because at the end of the day, you have to, usually you start small, you have some data, but then you figure out in the dashboard, the data is not as good, or there's missing rows, and I need now to clean this date format, or as we have seen with this jet stream, there's a lot of JSON, right? You might need to normalize that data somewhere, and then they might change the format at some point. They will add new attributes, right? So you need to kind of, it will break at some point, and then, yeah, I did some Python code myself to actually export the jet streams, and first of all, you need to have somewhere that it runs, right? So I can run it on my local machine, but my local machine is not running all the time. So yeah, you would need to have like a Lambda function or somewhere to run in the cloud to constantly extract it. But then you need to land it somewhere, yeah, probably in S3, right? That you have like a cheap storage and you can like do later what you want. So schema on read, right? That you kind of figure the schema later when you actually want to analyze it. So, but usually is if you want to really implement a real analytics on top of it, I would actually start way back, that you really have like, okay, what is the data flow? What is my data engineering life cycle? What do I need to, because orchestration is one part, but you would also need to have kind of the lineage maybe, or you would need to maybe you would have like a data catalog where you see your data, right? It doesn't need to be a tool, but it needs to be some kind of query that you can see all your data. Yeah, you might do, you need a BI tool. So it's like, I think these thoughts or these brainstorming activities also get a little bit lost, or at least in what I read sometimes, because you just have some data, but in a real enterprise, you actually need to make it sustainable. And you need to kind of you need to adapt to the changes, because schema change, I also wrote about, like my last chapter was about the schema changes. And I analyzed the convergence evolutions between different schema changes, right? We have like, when I started, we just had like a kind of release management team that organized all the changes. And if the release was closed, you couldn't change anything anymore. And then you had to wait to the next release. And then, we had like slowly changing dimensions where you can kind of, the changes of the data is has an evolution. You have data vault, like a methodology that actually automatically adapt, or more automatically adapts to changes in the source system. You have some schema registries. And I compared that then to NoSQL, because in NoSQL, you don't have any schemas, right? Or like you have a flexible schema. Or nowadays you also have data contracts, which is basically a similar concept, but you have a contract that like the source and the destinations agree on. So but looking back to my when I started 20 years ago, we still do this schema evolution or schema changes, right? That didn't go away. It's just maybe not the first thought when you start, but when you actually start and you think about that thoroughly, I think it's you will be in a better state at the end, right? That you can really foresee, okay, what happens if the Bluesky changes something in the AT. Actually, I saw like a PR recently that actually said something about the jet stream, that they changed something, and then it's the apps don't need to change, but actually the one who consumed the jet stream, right? And so that's just some thoughts that come to mind. Maybe
on schema evolution, of course, right, is one of those you know persistent challenges in data stacks, and certainly I think one observation, there's a quote I think out there that someone said, all money in software is made with either one of two strategies, bundling or unbundling. And I think what we saw during the last couple of years, initially with the so-called modern data stack, was a pretty significant unbundling of a lot of different features of data analytics and data engineering, where you had many businesses being formed for doing all the different parts of, you had businesses around data catalogs, the guys who started this company Amundsen, right? I guess it's a open source project at Munson that had a company that was built around it. You had companies around data contracts. You had companies around metrics layers, right? And so there was a real proliferation of a kind of unbundled data stack. And I think now, fast forward a couple of years, it does feel like several of those companies have been acquired. I think DBT acquired one of the metrics layer companies, the authors of metric flow. And I think another one of those companies pivoted into a different direction. But now we're seeing more of a I think at least more recently, a bundling where folks are realizing they maybe don't want to have when they're building their data stack, they don't want to have 17 different SaaS vendors in their stack. But and potentially, some of the challenges of schema, you talk about schema evolution, is that the more moving parts you have in your stack, the more, it's almost like a game of telephone, I guess. The more likely things are going to get broken as you move data from ingestion to object storage to database to metrics layer to BI tool. And another piece that obviously we collaborated on, which maybe addresses some of these moving parts and how we deal with schema evolution and just change management, right, in the data stack, is you wrote about the declarative data stack. And I think you and I both have observed that one way to wrestle some of the complexity of the AT protocol changes their JSON schema, which then leads to a whole set of knock-on effects across someone who built a Bluesky metrics dashboard. If they change their AT protocol JSON schema, like there's a lot of stuff that needs to be managed with that change. The declarative data stack seems like it's a philosophy, right, where some of these problems are made a little easier, a little more soluble. Maybe tell us a bit about you came up with that term, declarative data stack. Tell us a bit about what that means, like what problems it addresses, probably is the most valuable thing about this declarative data stack, and some examples maybe you've seen. Obviously, I have a horse in this race, but you have more of a independent lens as someone who's working with several different businesses out there.
Yeah, I think it connects well with if you have multiple tools floating around and you need to kind of integrate them. It's very hard if you do that like imperatively, it's kind of imperative means that you kind of define the how, right? You implement how you want. Let's say if something changes, you need to kind of implement that into your code, so to speak. And the core concept of the declarative approach is more that you only describe the what, so what you want. It's like SQL, right? You don't SQL. It's not so true everywhere because you have there's different SQL languages or dialects, but SQL in general, you don't say how you want to query the data, right? The engine itself, it can be different engine. It can be one ClickHouse. It can be one in a SQL Server. They have their own optimization. They run their query plans, and then they try to see if there is like an index on it, and they manage that themselves. You only declare what you want, and that makes things much easier, right? So if you zoom out and at the end you just say you want, I just want to have a BI dashboard, but I still need the data, right? If you somehow can declare that in we discussed this in the article, right? That if we could do that in a single function, that would ease up things, right? Because then you have like a similar concept that Kubernetes has, that you actually define all your things in one YAML, although they can be quite large, but it's like one specification, but Kubernetes itself will like then try to solve or bring it into that state, right? So let's say if a pod is like down, it will try to ramp up the next one. So you don't need to, you have less less complexity, and yeah, you can better integrate multiple tools. That is the ultimate goal, right? That is that you have less complexity, and you can also integrate different tools. Obviously, that needs some kind of interactions between the tools, but that's the vision, right? That you have like, it's almost like also another example is like Markdown, right? We have you can write Markdown in your Obsidian. You can write it in, even Google Docs has now a Markdown export and import. There's you actually decouple the compute or the engine from the actual data, which is the text in that case. So different engines can be built, and they can do the how, right? How do I convert this now to like a text that everybody can read, right? So and the same thing could be that we have like we have one declarative stack that we can define what we want, but then there might be different engines, right? That you have maybe a engine that even sub engines, right? And orchestrator could be one engine, but there's different orchestrators, so every engine. But if we have one definition of, let's say, we want a transformation, we want to clean the data, that if we can define that declaratively, then each engine can actually read that and do their best in their own in their own parts, right? The orchestrator will do the best orchestration. It will do it better than a BI tool or a ingestion tool, right? But the BI tool will much better show the data. So yeah, if we can combine these into one single function, that would also go well with the functional data engineering philosophy, right? That everything is like repeatable, and you can have the same. It's like an idempotent that you can restart with the same data and you will get the same outcome. Because the hard part about data is like you have state, right? And the state you cannot. You also have upstream data that you cannot influence. So the blue sky, we cannot tell them please don't change anything, or please don't write any asterisks in your post, right? That is out of our hands, right? We can maybe say, okay, I also read some blogs, they specifically didn't choose Markdown because they have some weird edge cases that what if someone writes a Markdown but actually don't want to, and stuff like this, right? But yeah, it's yeah, a really fascinating topic. It's not always the best, right? If you have a small stack, I think like imperative workflow and implementing everything maybe in a monolith or something might be even better. But if you have really large, complex systems, that's also why Kubernetes is mostly used in large organizations, then it's really a game changer in my opinion. And that's why I'm really fascinated by tools that actually allow this, like Rill as well, right? Because I had built BI dashboards all my life, and it was always hard to actually like just duplicate a dashboard and maybe change metrics or because you need to click that, and it's hard to actually store it. So yeah, I don't know, that's kind of it's a vision, I would say, right? It's very hard to have end-to-end declarative and then integrate that. But I think it's a good vision to have in the back of our minds, and to try to yeah, it makes also the integration easier, right? If you have a clear define, it's almost like the data contracts that you define the interface, and then the orchestrator and the BI tool and the data catalog, they can always work against this interface, right? So you have kind of a contract, which is the declaration. So of course, then you need to say you need to have a standard declaration somewhere. But yeah, I think that's it's a good way to follow, or to try at least. Yeah.
It seems that yeah, particularly in the data world, if you look at sort of the evolution of different technologies, one example would be in the early days of Hadoop, where you had MapReduce, and a lot of data processing for a long time has been a lot of when I think about data pipelines and about kind of getting data from point A to point B, and then data transformation in particular, I think for a long time, a lot of data transformations had been imperatively defined. So folks would use tools like, they would use Java, or they'd use uh, probably Python is now one of the more, most popular. But it does feel that there's been increasingly, SQL is no longer being used just for querying data, but increasingly, SQL is being pushed kind of down the stack into the transformation layer.
Mm.
And I guess one observation would be that the challenge of putting SQL in the transformation layer is that, as you mentioned, this sort of declarative approaches separate the what from the how, and when you separate that, you often and data transformation is kind of often important to performances of one of the highest concerns, and you kind of need to have control over the how. And so it's only recently it feels that um, that SQL has started to become more and more used in data pipelines for transformation, rather than rather than Python or Java or other code.
Yeah.
And I guess I would observe that this ELT movement was about loading the data. I think Snowflake, for self-interested reasons, was very much pushing folks to load data into Snowflake and then do transformation
Mm.
there in Snowflake. And the appeal of that was that, great, we can use SQL, which is a much just nicer language to work with data. We'll import all of the data into a Snowflake table, call it the raw data, and then do a series of transformations. Of course,
Yeah.
I think people woke up to the fact that that was extremely expensive, right? Um, Maybe what were the promise of DuckDB on the data lake is that you have kind of all of the benefits of a declarative grammar or declarative, SQL for data transformation, but you don't
Mm.
have to pay the Snowflake tax, and nor do you have to pay the network fees, right? Of moving the data
Mm.
from your, S3 bucket into Snowflake, and then, paying a 5x premium on all your compute cycles.
Yeah, I think one of the keys there is also the openness of the format, right? If you have it goes with any data warehouse, right? If you put it also in a Azure data warehouse or so, they're kind of locked into this proprietary format that you can query with their tools, mostly SQL, right? But you don't have access to the engine, as you said, yeah, or the compute, right? So it's like if you have an open format, I think that's also why they're so in trend, or why they're so, because if you as a company can now store your data, which is the asset of every company is their data, right? If you can now store that in a format that is open and even accessible, you can now it's opened up so many possibilities, right? You can now use other tools to actually do the compute, maybe locally, or you can do you run an orchestrator and use something to run on it. But you even more, right? You can now you don't need to move the data anymore from one data warehouse to the next. Maybe you can even use the like a sharing delta shares tables. I think live tables you can actually share. So instead of, it's like sharing a Dropbox links, right? You just share the link, and then people can with any tool can actually query the data directly, instead of having a heavy or duplicating the data, right? That's another benefit of it. But I think the key is really, but it's really nice to see also the big vendors that they actually, like Microsoft, I think they implement now Delta into their Azure data warehouse. Snowflake has like the iceberg tables. So
Right.
it's really a benefit for everyone, right? That they're like the open formats, and then the community can also build tools on it. But for me, that this is really a big win. Yeah. Oh, and then but again, then usually what happens is you have like kind of a data lake then that is a little bit a data swamp sometimes, right? Because you can just easily dump now data, you can easily read everybody. That was the advantage of a data warehouse. You had like a core team who kind of make sure the quality is okay, the data is updated every day. But if you make it more open, people also just like the data scientists, they go there, they do their stuff, they copy the data. So it's more, before I said you can actually easily share without copying, but the copying happens because it's open and accessible, right? So it's yeah.
A
Yeah.
double-edged sword.
Yeah.
Right. Well, I think that gets to you know, right, one of the we talked a bit about, and maybe we'll sort of come to the last topic of our discussion, which is, I think, the something that those of us who've been working in data for a long time deeply appreciate is the importance of data modeling. And I think for some time there was this feeling in the early days of big data that you know we could just have unstructured data, the data lake, aka the data swamp, right? We can just do kind of schema on read, and we don't really need to do much modeling. We'll just dump all of the JSON event streams into a data lake, and then the application layer will take care of the transformation. But I think probably the real world experience, time and again, we were talking about what's changed in the last 20 years and what hasn't changed, is that SQL continues to be pretty important, but also data modeling continues to be of incredibly relevant. And without data modeling, you'll just end up with garbage in, garbage out, right? I think
Totally, yeah.
Pedram has a Pedram, who I think was Pedram Naveed, who now works at Dagster. He has a long running joke on Twitter and maybe now Bluesky, where he's like, have we agreed on what the definition of a user is yet, right? And many of us know that just the simple act of counting things, like how much revenue do we have last month, how many users do we have last month, there can be a lot of discrepancies depending on how the data is modeled, for what the answers to those questions are.
Yeah.
I'd love to hear your perspective on what recent evolutions have you observed in data modeling, around the modeling of metrics, of course, is a topic of interest around modeling modeling data in tables, modeling data in data lakes, materializing models. What are some of the trends you've observed as you've been writing your book and working with a number of leading companies in the data ecosystem?
I think the metrics is one that is really fascinating to me, that you have like again the declarative definition of metrics, that you can have them in one place, and then you can sort of even like give APIs to the consumers, right? That they can have a SQL API, but maybe some would like to have a REST API. Some would like to have a MDX API to query it with Excel, right? Excel is still quite a famous BI tool. And but you have to have somewhere a definition of metrics to actually allow this, right? If you have the metrics in maybe different BI tools, or if you don't have a place where you define them, you end up with having the same definitions multiple times. And at the end of the day, what I experience is also that no company is the same, right? So the profit is in every company is different, and some have a huge history of how that is calculated, and there's so many factors that go into that supposedly simple KPI. but it's also where the business modeling or the business value comes from, right? To really like implement this business rule. I think this SDF has also what struck me lately was they have like a business rule as code. So
Mm,
they say they actually, if you have different rules, like a customer in one tables and in the other, right? They always have different names maybe. So you can define a rule in one place and then you can have that. So that would be the next layer, right? That you have the metrics and the rules, and then you have maybe the transformation. So this is a interesting aspect. Another one is like also one that I wrote about, like the materialization, right? Or caching, right? Where do you cache? You can cache so many places. You could cache if you actually dump your Bluestream data or Bluesky data into like a S3. It's a form of caching, right? You just store it there so you can faster like aggregate stuff. But then you can put it in an all-up cube. So then it's sub-seconds, right? So it's another cache. But you can use dbt, which is basically doing aggregation on aggregation, which each of them can be cached, but it can also just be a view. But it's like that's the whole point of modeling, right? What do you want? Do you want fast? Do you need fast query time? Then you cache probably at the very end. Maybe you don't mind about waiting 5 minutes for your data science query, right? Because or it can even run overnight. So where do you actually persist and materialize your data is a very fascinating question. And that's one that is answered in the data modeling part, right? That you need to define. And I think that's also sometimes there's like the technical aspect of it, but there's also the conceptual modeling, right? That you have like a logical model that you can actually discuss with the business people. And then you define, okay, do you want the Bluesky data? Do you want that? Which granularity do you need it? Do you need it daily? Maybe you can have it weekly, right? Maybe that's enough for your use case. So then you can actually save a lot of money by just like saving it as a monthly partition. But then, what dimension you want to query it? So there we are in the modeling of the dimensional modeling, right? You need to kind of foresee what dimensions you want. And I think these are things that haven't changed a lot. I think what has changed almost on a daily basis is the tools that we use. So I'm actually very happy for that, right? When I go back to 20 years, at every company I was building the same ETL jobs over and over again from scratch, and you were not allowed to use the code take in the next company, right? So you basically started from scratch. But nowadays, many say it's a bad thing that there's so many tools, but actually, me as a data engineer, I appreciate so much, right? You can just go on GitHub, pip install, and then you have a whole ingestion. You have a BI tool, so you can actually pick and choose for free in a way, right? You just need to kind of learn the tools, build them together. But and there we are at the modeling of tools, right? So we have the modeling of tools, but you also have the modeling of the data. And then you also have the business requirements. I think if you put them in kind of a Venn diagram, I think if you find the sweet spot there, you're probably in a good position to. But sometimes we are, me included, we are a little bit into the fancy technologies, right? Because that's fun, and it's also cool how if you can just in one simple query have like show my Bluesky tweets on my terminal. So that's really cool. But you should always start with the use case, right, from the right side, and then go to top down.
Shift left, right? As we say, right? You kind of start with the business requirements and then move backwards. I think that, right, that's probably what makes data modeling so difficult, because it's not just a technical problem. It's actually it sits at the interface between the technologies and the actual business. The definition of how you count a user, or how you count, profit or revenue, ultimately that's a business definition, and so it requires integrating some business domain knowledge into that. I think the other interesting thing around data modeling is that I think there's enormous opportunity for efficiencies to be gained with better data modeling, but unfortunately, many of the businesses and many of the technologies that are out there have perverse incentives to not want their users to be efficient data modelers because they get paid for consumption. They get paid on compute cycles. And so
Yeah.
generally Databricks and Snowflake as kind of the two probably big gorillas on the the technology stage. They it's not really in their interest to get people to think about more efficient data models or caching layers that would reduce their consumption of only reluctantly will they be brought along on that.
Yeah, I think it's also first of all, if you're not writing code, right, you're not working, right? So if you're just thinking, and that's not really the work, right? You cannot show off that. So it's like hard to quantify that value. But on the other hand, it's also actually when you use a Databricks or Snowflake, it's you have something in a day, right, or in hours, right? So it's really easy to get started. That's also actually the benefits of compare back to, like, if you build a data warehouse. Sometimes back in the days we were talking about 3 months just to have the first dashboard or the first KPI, right? So it's a different mindset. I think today you can do it much faster. There's data warehouse automation. There is like agile data warehousing and BI approaches, right? You can be much faster also in the modeling phase, but it still takes time, and you need to be willing to actually pay that or actually invest in that, right? So it's also a bit, I see it a little bit of the responsibility of a data engineer or the engineer itself, right? That push a little bit back in the beginning and say, okay, now we need to like kind of think through that and take some time in the beginning, because usually you pay back that magnitude higher, right, later. Because if it's something wrong, then we actually go into this CMOS changes and we need to change everything, right? And then if you have a better model to start with, you have much less friction. And yeah, I think you will end up in a much better place if you think about that.
Well, it probably maybe we'll end on that insight, which is one of the most important qualities in my experience of a good data engineer or a good data practitioner is judgment and taste. And that means the ability, as data folks, you're often sort of dropped into the fog of war, right? When someone says, "Hey, can we make sense of this data?" And while we all
There's good memes for that, yeah, also.
well, we all think that, yeah,
Mm,
the world is well structured and there's
yeah.
good documentation and annotations of, I think, in my experience, which I'm sure is also your experience, we're
Mm,
often just thrown into, here's a login to a database. Uh, the column schema has never been documented, and
yeah,
Carol, who works in the Utah office, you can just ask her, what that
yeah.
CT underscore
Five,
column,
6, 7, 8, 9,
right?
yeah.
What that means, right? So I think just the ability to have good taste and sort of good judgment and how to navigate the decisions under uncertainty is a really important. It's not just technical prowess, the ability to write code that's efficient and performant. It's sort
Mm,
of somewhat softer skills. Maybe that's the
mm.
EQ of data versus the IQ that can really, I think, be the.
It's actually really interesting, right? Because that goes really in the next topic that we didn't even discuss, the Gen BI, right? Because there we have another component that actually generates stuff out, and then the human gets even more important to actually verify and to
Right.
not generate things that might be just totally wrong. But yeah, I think that what you just said, and it will get even more important with the AI and generative stuff. So it's yeah.
Right, and right, increasingly, I think that's a great point. Is that increasingly, you know, AI and whether it's Cursor or Claude or GPT 4.0, these things are they're increasingly good at the technical execution, but what's needed from still on the human side is to provide some guidance, some judgment and some, frankly, some curation or evaluation of what the outputs are. Is like, does their answer make sense? You know, when you ask.
Yeah. It sometimes also just a feeling, intuition, or just like experience, right? Some things you cannot just only know by experience. So it's yeah.
Well, listen, Simon, it has been such a delight and a pleasure to have you here on the Data Talks in the Rocks
Thank you so much, yeah, for having me.
session. I look forward to maybe a future. We'll have to get further into this topic of Gen BI, which I know you recently wrote about. For we collaborated on that essay of late. We will share some of the links in the blog post that we'll put up with the transcript for anyone who's interested in following some of the things we discussed, whether Bluesky and Jetstream and some of these different articles that we've all been reading. We'll also share both your and my Bluesky handles for those who want to, continue to follow these, follow us online as we enjoy
All the starter packs and
exactly further expanding on these different discussion paths. Thank you again. I look forward to our next discussion, and thanks for joining us here.
Yeah, thank you so much. It was a pleasure, and yeah, looking forward, for the next article and discussions. Yeah, really appreciate it.